Transformations of a quadratic function. When we say transformations of a quadratic function, we are referring to the simplest of all quadratic functions, f of x equals x square, whose graph we saw in an earlier video is a parabola with vertex at the origin and axis of symmetry as the y-axis. So this is the graph of f of x equals x square. And in that video, we also saw one of the transformations, the vertical shift. So vertical shift happens whenever you add or subtract a number at the end. So something like x square plus 5 would move the graph up 5 units, but x square minus 10 would move the graph down 10 units. So this is covered. Now we will look at horizontal shift. So there are situations where the graph, instead of moving vertically up and down like in the previous shift, now will move left or right. So when does this happen? Well, it happens whenever you're adding or subtracting, not at the end, but let's say inside the parentheses and then squaring. So you're subtracting 3 first and then squaring. Now this is not same as f of x equals x square minus 3. Now what happens here is the vertex moves horizontally. And here is where students might get confused. If you see negative inside the parentheses, x minus 3, then if it's a horizontal shift, it's actually a right shift of 3 units. So your vertex now moves to this point, which is 3, 0. So your vertex moves or your entire parabola moves 3 units to the right. Now the way I think about or I try to remember is, if I want y to be 0, this is y, then what do I take x to be? Well, if I take 3, then 3 minus 3 is 0. So that's why I want to have x is equal to 3 here, which means x is positive 3, so we are moving to the right 3 units. Now on the other hand, if I have an equation that is x plus 5 quantity square, then what kind of shift am I going to observe? This time, if x minus 3 quantity squared caused a right shift, then our guess is that this will be a left shift, and it is correct. 1, 2, 3, 4, 5 on the left side. So it moves 5 to the left. So this is the graph of this function. And again, if you want, what should be the value of x so that y is 0? Well, it should not be 5 because 5 plus 5 squared is not 0. On the other hand, x should be negative 5 because negative 5 plus 5 is 0, square is 0. So these are called horizontal shifts. So what is a horizontal shift and when does that happen? It happens whenever you're first either subtracting or adding to x and then squaring. Your basic function was squaring. You were squaring the input. Now, in the vertical shift, you would add or subtract after you square. Here, you would add or subtract before you square. So we covered vertical shift and horizontal shift. Now let's look at an example where we have a combination of both. So let's call it example 1 and write down this function f of x equals x minus 2 quantity square plus 5. Now what do we notice? We notice that it's not x square. We are first subtracting 2. And you're seeing x minus 2 in the parentheses. So that would cause it to shift right 2 units. And also, we are adding a 5 at the very end. So that's going to cause an upward shift of 5 units. So this is a horizontal shift of 2 and horizontal to the right. And this is a vertical shift upwards 5 units. So in the base graph, the vertex was at the origin. Now it's going to be 2 to the right and 5 up. So it's going to be at this point, 2 to the right and 5 up. And this is where you begin drawing your parabola. So your vertex is now at 2, 5. Here it was at negative 5, 0. There was no vertical shift here or here. But here there is a vertical shift. So with this we covered vertical shift, horizontal shift. Now there are actually two other transformations. Let's use a fresh sheet of paper. This would be called vertical stretch. Now for vertical stretch, so how does vertical stretch look? If I have a coefficient in front of x square, so say 3x square, then I need to draw the graphs of both x square and 3x square. So let me draw in different colors. So let's go ahead and draw the old y equals x square graph. So this is the graph of y equals x square, or f of x equals x square. Now, what the 3 does is it brings the graph closer to the y-axis. So you say that the graph gets stretched vertically by a factor of 3. And how do you address that factor of 3? Is when we look at the first graph we drew, this is how we drew f of x equals x square. We draw the vertex and then we move right 1 and up 1. And correspondingly left 1 and up 1 because it's symmetric about the axis of symmetry. So we can focus on only one side. So when you have a coefficient of 1, it was moving right up, 1 up. Now, so here for the y equals x square, if you move right 1, you go up 1. But here if you move for 3x square, if you move right 1 and up 3. So you move right 1 and up 3. That's why. So the red height is 3, whereas the blue height is only 1. That's why the red graph is closer to the y-axis, because all points are stretched or they have more y value. So that's how it works. Now, if the stretch factor is less than 1, like say half, let's draw the graph of that as well. So if I want to draw f of x equals half x square, then it will stretch by a factor of half, which means it moves away from the y-axis. So let's again go ahead and draw the graphs of both y equals x square and y equals half x square. So this is the graph of y equals x square. Now, y equals 3x square moved closer to the y-axis. This will get flatter. It will move away from the y-axis. So this is the graph of y equals half x square. So that's vertical stretch. Now there's one other transformation. It's called reflection. Now what is a reflection in the x-axis rather? It's already symmetric in the y-axis. So when do you have that? When you have a negative sign in front of x square, that will cause the graph to reflect in the x-axis, meaning your x square graph was opening up, now it will open down. So your parabola goes down. Now, notice that in both vertical stretch and reflection, the vertex does not move. The vertex stays where it is. It was at the origin for y equals x square. For y equals 3x square again, it's at the origin. Same thing for y equals half x square. The vertex is still at the origin. Now for reflection, it's again at the origin, but it opens down. Now let's look at an example where we have all four transformations. So let's write down. So what I need is to have a negative number, to have negative in front of x square, and also a stretch factor. So let's say 2. And now instead of x square, I'm going to have say x minus 3 quantity square, and then I will say plus 7. So when you look at this quadratic function, it has everything, all the transformations, all four transformations. X minus 3 inside the parentheses tells me that there will be a horizontal shift to the right 3 units. Then the 2 in front will tell me that there is a vertical stretch by a factor of 2. And then the negative in front tells me that there will be a reflection. And then the plus 7 tells me that the graph is going to move up 7 units. So what I could do is I could first graph the vertex. And you can see the vertex is no longer at the origin, but I want to know where it has moved. The shifts, horizontal and vertical shifts, will tell me where the vertex is going to be. It's a right shift of 3 and an upward shift of 7. So I go 3 to the right and up 7. So that's my vertex, 3, 7. And now the vertical stretch is 2, which means if I go 1 unit to the right, then I'll have to go up 2 units. So 1 unit to the right means the x value is 4, and 2 up means this is going to be 4, 9. Now I'm not going to draw a solid parabola because I know I'll have to reflect it. So this is the vertical stretch, and now I'm going to reflect it, which means I go to the right one and down 2 instead of up 2. And similarly, I go left 1 and down 2 because it's symmetric with respect to this axis. So this is the graph. Now you might notice that whenever I have something like a parentheses x minus h quantity square plus k, then I can write down the vertex quite simply as x minus h tells me there's a shift of h units to the right and k units up. And then the axis of symmetry is a vertical line, so it always has x equals something, and it passes through this point. So x is equal to h is the axis of symmetry. So to summarize, we looked at 4 transformations: vertical shift, horizontal shift, vertical stretch, and reflection. And then we looked at a quadratic function might look like this. If it is in this form, then it's easy to draw the vertex. It's easy to tell where the vertex is. That's why this is called the vertex form of a quadratic function. Because the vertex is h comma k. And the sign of a will tell me if the graph opens up or if it opens down. So that's all for this video. There are no practice problems again because we still have to cover the standard form, and after that we'll get into the problems. So standard form would be standard form of a quadratic. We'll see how to graph that, and that would use completing the square technique, and there will be practice problems after that lesson. Until then, I'll see you. Thank you.